Alright, hello and welcome to the first example in the destruction part of this course. Here we're going to take a look at how to use the bullet solver, rigid bodies, and how to do some destruction of certain elements, and how to shape it, how to simulate it, and how to basically work with it in the .NET and on the sub level. So in the first example here, we're just going to take a look at a very simple part of it. We're gonna take a box, we're gonna move it up a little bit, and then we're just gonna drop it and see what the physics does to this box. So first of all, we're gonna create this box here. We're gonna make it a polygon mesh. We're gonna divide it into 4, 4, 4. We're gonna move it up a little bit with an X form or a transform. Give some rotation, some translation. I guess we get it up from the ground plane. Then we're gonna put an out null here that we're then gonna later access in the .NET. And that's all we need to do here on the sub level, really. So that's all. Then we need to drop it down on .NET. And in the .NET, you remember we do pyro, we do particles, we do all these things, and we can also do rigid bodies. Rigid bodies has a very vast set of nodes as well inside of .NET. So I'm gonna go over a couple of them in this course. So yeah, let's dive into .NET. Inside of .NET, we have a couple of nodes here now. Most of them are new to us actually. So I'm gonna go from the top down. All right. So first of all, we need to bring in the RBD object. We're gonna click the display flag on this one. Excuse me. In here, we need to access the object, right? So if I just have like this, as a plain one without any subpath here, we don't get anything, right? We just have a node. So it's called RBD object. That's the name of this node. And this is how you bring in objects to the solver. There's a couple other ways to bring in objects, but this is the most basic one. So the RBD object has multiple things. We can go over them in future tutorials, such as an interstate, the glue, the collision, and physical. For now, we're simply gonna bring in our object. And the path to that was this. You basically have to find the null that we dropped down in sub level. Point it here, and the object will be brought in. Now this object, if I press play now, is not simulating at all. It's yet there in the same initial state as we bring it in. To apply physics to this, we need to apply the RBD solver, or we need to connect this to our RBD solver. This RBD solver doesn't really have that many like parameters to it. But what it does is it basically solves everything that is connected to it. So if you have multiple RBD objects, you can put a merge here. You can merge multiple of these like that. So if we do initial state and we move it a little bit, and we can see here merge, and then we go here, you can basically solve both of these objects like this now. But we don't want to do that now. We only want to solve one object, so we're gonna do that. Here you can connect some other like input data. I might go with it in the future tutorial, but it's a little bit over course, so let's not worry about that now. Then, as we see here, this is a solver, right? So it will solve this. It has some iterations and sub-steps and stuff like this to get a more accurate solving of the objects, but it won't really do anything. This doesn't apply any physics to this, right? So we need to do that later on here. But first of all, we're gonna drop the ground plane just to get some collisions. The ground plane we used before. We can basically just merge it in after the bullet solver. Put a ground plane and put it to the merge, and in the second input of the merge, we put this. Since the merge is put to left inputs affect right inputs, that's what we want. We want the ground plane to affect this, not the opposite, right? We can put mutual, but that is slower to calculate, and since we don't really need the box to push the ground plane, we can put it to left input affects right input. Next up, since we see here, this doesn't do anything. We still are not solving anything. We're not putting any physics onto this. We're gonna put the gravity. The gravity is defaultly set to -9.8, which is the physical like number for gravity on Earth at least. But yeah. This will actually apply gravity to this box. So if you now get the display flag on this and we press play, the box is falling down and it's bouncing a little bit and it's came to the rest. That's cool. So now we finally have an RBD object with some physics to it. As I said, we can actually copy this if we want. We can merge it. Now afterwards, we can do that. In initial state, we can move it a little bit, like that. Maybe rotate it a little bit. Never mind. Anyway, we can do this, and then we can press play again, and we solve both objects. So that's a pretty cool introduction, I think. We're gonna do much more intricate and like advanced things, but this is the basic of it. So to reiterate, we bring in the object, we put a solver to it, we put some collision objects to it, and then we put some physics to it. We can bring in velocities, we can bring in stuff like this to make it like behave differently in the first frame. We are gonna go over that in almost the next example, I think. But yeah, this is the gist of it. So if you wanna read through this and go through the example, I encourage you to do that. But that is all. I'll see you guys in the next example. Thank you.